This question is based on a really common and really useful application of normal distributions in industry, in particular in quality control. And the idea is when a manufacturer is making some sort of product that has a certain lifespan, often that lifespan for individual products is going to be normally distributed. And by learning a little bit about that distribution, using some experimentation to find the mean and the standard deviation, the manufacturer can learn a lot more about how their product performs. So what we're told here is a certain model of light bulb is found to have lifespans that are normally distributed, and the mean is 1600 hours with a standard deviation of 300 hours. We're then asked to find what percentage of bulbs would you expect to last longer than 1900 hours. Well, notice that 1900 hours is exactly the mean plus one standard deviation. That's what makes this an empirical rule problem. And through the magic of modern technology, the empirical rule diagram appears. Let's see if we can adapt it to this situation. The mean is what always lives in the center of the normal distribution. So this is going to be 1600 hours here. We've already decided that one standard deviation above 1900 is the time we're interested in. And the proportion or the percentage that we're interested in is the part that lives here to the right of 1900. Well, let's just add up the areas that the empirical rule gives us. We have 13.6%. Next portion is 2.2%. The last is a tiny little 0.1%, and when we add those together, we get a total of 15.9%. So it would be reasonable to say that about 15.9 or maybe about 16% of the bulbs would be expected to last longer than 1900 hours.